In the last two demos, we integrated the Fluent validation library into the ASP.NET pipeline. We used this NuGet package for that. It allowed us to use the standard model state property to get the information about validation errors. The way it works is the Fluent validation library first looks at the type of the incoming data contract, such as register request. Then it automatically resolves the corresponding validator class, since each validator is defined for a specific data contract. After that, the library uses the validator to check the incoming data contract and populates the model state property with any validation errors it finds. Note that if you are using the default ASP.NET dependency injection container, you can only have one validator per data contract class. So you cannot create two validator classes for the same data contract, which you shouldn't do anyway. It's just something to be aware of. We have also automated the model state checks using the API controller attribute. Now we don't even need to check the model state is valid property. The controller marked with this attribute does it for us automatically. We also don't need the from body attributes, since the controller now automatically infers the binding source for the incoming data. The last feature we'll look at in this module is building custom validation rules. Custom validation rules are useful when you want to create a rule for a non-standard type and reuse it between different rule chains. Let's see this in practice. Look at how we're validating our collection of addresses. We are using the must method, which is a good option for non-standard rules that you only need once, but not ideal if you want to reuse the same validation logic. We can fix this by extracting this logic into a custom rule. That will allow us to simplify that rule and also reuse for other collections, should we have any. The easiest way to create a custom validation rule is by defining it as an extension method. I will use this class called custom validators to do exactly that. I will name the rule list must contain a number of items. It will accept the rule builder, the minimum number of items, and the maximum number of items in the collection. Notice that I'm defining the minimum and maximum values as optional. This will allow for additional flexibility. We will be able to check for only the minimum or only the maximum number of collection items. In the rule itself, we will be calling the custom method. This is a low-level method that allows for more granular control over the validation process. In it, we're checking that the minimum number is provided, and if it is, we're checking that the number of items in the collection is equal to or greater than this number. If it's not, we're adding a new failure to the validation context, where we're specifying the property name and the error message. Note that it's a good practice to indicate not only the minimum number of items, but also the current number of items in the collection. We need to do the same with the maximum value. If it is provided and the number of collection items is greater than that number, then we're adding a new failure to the context, indicating the property name and the error message. And I need to change the return type of this method. Now we can use this method like this, specifying the minimum and the maximum number of items. And we don't need these lines anymore. If we ever want to check only the lower or only the upper bound, then we can use the named arguments like this. Alright, let's run the application and make sure that our new validation rule works. If I remove the address so that the number of items in this collection becomes 0, and send this request, you can see the error saying that the list must contain at least one element. Same with the maximum value. If I write down 4 addresses and try to send this request, then the API returns another error message. And if I leave only one address in the list, then the student is registered successfully. And I actually need to fix something here. You might have noticed that our API returns an incorrect field name. That's because if we look at this method's signature, you can see that it has an overload that accepts a property name and another overload that only accepts the error message without the property name. We don't need to specify the property name here because Fluent Validation already had this property in its context. We only need to pass the property argument if we want to append the field name that Fluent Validation returns for this error. For example, if the error referred to a specific item in the collection, then we could pass the index of that item so that the resulting response would point to that item. Let's run the application again, send the request, and you can see the property name is now displayed correctly. Very good. In the previous demo, we discussed how to implement custom validation rules in Fluent Validation. The easiest way to do so is by introducing an extension method on top of the type, objects of which we want to validate. Here, that type is any type that implements the iList interface. In the extension method, we used the custom method from Fluent Validation. This method is a lower-level method that allows for more granular control over the validation process. Notice the difference between custom validation rules and custom validators. Custom validation rules help us to reuse a single rule in a rule chain, while with custom validators, we are reusing validation checks for the whole rule chain. This concludes the first part of the course. In this part, we discussed the Fluent Validation library and its features. In the next module, we will talk about validation best practices in general and how the topic of validation relates to domain-driven design. In this module, we discussed more advanced features of the Fluent Validation library. We talked about conditional validation and the two ways of implementing it, within a rule chain and as a top-level method that allows you to group multiple property checks under one condition. You saw how to set up the cascade mode. By default, Fluent Validation invokes all rules in a rule chain, regardless of whether one of them fails. You can override this behavior such that if one of the rules fails, the library will not validate the subsequent rules in the chain. You can also configure the cascade mode between different rule chains. We've integrated Fluent Validation into the ASP.NET pipeline. This allowed us to use the standard model state property instead of instantiating the validators manually. We've also automated model state checks, so that we don't have to check the model state manually. Finally, we discussed how to implement custom validation rules, such as, for example, rules for how many items a collection must have. In the next module, we will talk about the topic of validation in the context of domain-driven design.